Goeie namiddag voor deze expertclass. Verwelkomen we Jan. Jan zal zijn sessie geven over het schuren en ontbramen op basis van cobots. Voor zover ik zijn sessie bekeken heb, vond ik het een prachtige sessie die eigenlijk in een notendop ook zegt dat cobots zijn niet alleen omwille van het collaboratieve interessant, maar ook, als ik het goed begrepen heb, de manier waarop ze zo flexibel en snel hergeprogrammeerd kunnen worden voor variërende kleine series is echt wel amazing. Ik zou zeggen een hartelijk applaus voor Jan. Vragen kan achteraf uiteraard bij een pintje of een koffie aan de bar. Tot straks. Dank u wel.
Dank u wel. Goed. Welkom iedereen op deze expertclass rond cobot finishing, of zoals reeds gezegd werd, het schuren en ontbramen met cobots. If it's okay for everybody, I will switch to English so that even if other language or other language-speaking people are present, everybody can understand me. Okay, my name is Jan Kempeneers, as already said. I work at Sirris, and maybe for some persons present who don't know Sirris very well, Sirris is the collective center for the technology industry. And what we try to do is we advise and help companies to implement innovations. As you can see, we are located at some 8 different sites in Belgium, and most of the sites also dispose of a lab where we have domain-specific equipment. With this equipment, that allows us to do feasibility tests, feasibility studies, and build proof-of-concept setups for companies. But at the same time, it also gives us hands-on experience, so that we can give advice to companies based on hands-on experience, actually. Okay, so this talk is about finishing with cobots. And when you say that, or when you hear that for the first time, I can imagine that a lot of questions come to your mind. First of all, why the hell would you want to do that? I mean, isn't the cobot meant to be safe around humans? And how can that be with a grinding tool? Is a cobot not meant for lightweight applications, clean environments, and isn't grinding a more dirty and dangerous environment, and things like that? And even if you would want to do that with a cobot, can a cobot do that at all? I mean, can it achieve the required finishing quality? Can it handle the vibrations caused by the process, and so on? So all these questions, I hope that I can give a little bit of context and some answers to those questions during my talk today. First of all, let's start with the question why. Why would you want to do that with a cobot when these industrial solutions exist, and they exist for many, many years, decades even? So why would you want to do that with a cobot? Well, this is the reason why. Because this is the reality at most SMEs, at most small and medium-sized enterprises here in Belgium. And in my opinion, that is already a good reason why you start looking for alternative approaches when the other approaches do not satisfy your need, okay? But then remains, of course, the question, yes, okay, but if you cannot find a solution for this small series work, it's still an industrial and a heavy and a dirty process. Can a cobot really handle that? Before we dive into that question, let me take you back a few years, a few steps back, to what Sirris has been seeing in the market when we started following the trend of cobots. That was around the year 2012. We have seen at regular intervals company contact us with the question, can you deburr this product, or can you grind this product? And I just want to show you a few of them, so that you get a feel of what kind of questions that we encounter from the companies looking for alternative solutions to do deburring and grinding. The first case that I want to talk to you about is a case we did together with company Engie. It was a feasibility test, actually. I think everybody knows the company Engie. It's a big contractor. They're also into piping. And of course, when you say piping, you say welding neck flanges to the end of a pipe. That's a huge part of the work. Now, when they weld these flanges, they need to remove the coating from these flanges. And As you can see here, the flange has a yellow color, but that's actually a coating that has to be removed before you can start welding. And typically, the welder, he removes this coating, and then he starts welding. But as you all know, the time of a welder is very precious. You don't want to have him spend time on removing coating of a flange before he can weld it. So Engie was looking for an alternative solution. Their idea was, can a cobot not help remove this coating? And as you can see on the movie, we built a small setup where the cobot is actually sensing where the flange is positioned on the table and also calculating the diameter of the flange that is lying in front of it, so that you can put any flange on the table on any location, of course within the scanning boundaries of the robot. And then the robot calculates the diameter, calculates the center of the flange, and then does a movement to remove the coating. So the removal of the coating on this particular case is done on the inside of the flange. So the movement that the robot is doing at this moment is actually a force-compliant movement. So we are pushing with a constant force all the time to the outside of the flange, and thus we can remove this coating. This is just a small example that I want to show you. I'm going to show you a second one, and then we dive back into the story. So the second example that I want to show you is a project we did with a company called Group Nivel. Group Nivel is a manufacturer of bathroom furniture. So they make these wash basins, but also floor tiles and so on, and also side panels for in the showers. And they make those products out of a composite material, actually. It's a material that consists out of two components, and they mold it in open mold, so atmospheric molding, actually. And every part that has been molded needs to be finished, because when the part comes out of the mold, the surface is not fine enough. The surface roughness is too high to serve as a finished product. So every single product that they make, every visible surface has to be grounded smooth. And they already had some experience in the past with industrial grinding, and they were now looking for alternatives. So we did a quick setup, and we did a quick test with them to see whether a cobot could do this grinding, and especially for them was very important, how flexible can that be? Can our operators program that? Now, just to be clear on that, those two cases were not implemented at those companies, not the way we showed it here. Okay? They took other measures to improve on their process. But nevertheless, companies like this coming with those questions to us, they can see what is possible, they can see how easy or how difficult it is, and they can make a judgment based on facts. So, back to the original question. It's a dirty and a heavy industrial process. Why the hell would you want to do that with a cobot? I'm showing this picture with also a welding robot, cobot, next to it. A few years ago, 2017, we did a project together with Agoria and also together with the Belgian Welding Institute on cobot welding. And we had exactly the same reflexes, exactly the same questions came to mind from industry. Why the hell would you want to weld with a cobot? There are industrial welding cells. They are mature. You can find them anywhere. You have multiple suppliers. Why the hell would you want to do that? Well, my point is, and that's also why I showed the previous two cases, if companies find that some of the existing solutions do not meet their needs, then they will start looking for alternatives. And whether the device itself, whether the device cobot was meant for that application, they don't care. The only thing they care about is, can it help my operator do things faster? That's the only thing that matters. And nowadays, nobody looks strange at a cobot welding anymore. And the same will be for grinding. So that's actually the main point that I want to make. Is a cobot meant for this? No. Can a cobot do this? That's an entirely different question. And I think at Sirris, looking at these new technologies or these combinations of new technologies and find out where the boundaries are, what you can do with it. That is typically what we try to do for companies, to reduce the risks on their side for doing investments that may not suit their needs or may suit their needs and solve a problem. Okay? So remains, of course, the other aspect, safety. How can it be safe? Well, let's be clear about that. These are not applications where you use a cobot for its collaborative aspects or its collaborative possibilities or features. It's not the case. And when you look at the topic safety in machines in general, well, all machines are equal. There is no difference between robots or cobots or other machines. There's only the machine directive that needs to be followed. And the machine directive requires that you do a risk assessment, that you put in place all measures possible to reduce risks to a maximum extent. And the same goes for cobots. And in my opinion, not only for grinding and welding, but for all cobot applications. There are no cobot applications that you can do today, or practically no cobot applications that you can do today without additional safety requirements. And that is due to the technical specification 15066. Machine directive says you have to follow the standards. The standards give you the description of the state of the art. The standard 10218 refers to the technical specification. So the technical specification is the standard 15066. And this technical specification reduces your possibilities of building a safe system without additional safety requirements to practically zero. There are very limited cases where you can get away and claim that you still adhere to the technical specifications if you don't put additional safety measurements in place. So for that matter, grinding, welding, and other cobot applications, actually, they're all the same. They're all the same? No, that's not true. There is a difference. When you go welding or when you go grinding, because don't forget, the risk assessment, you don't only have to look at the machine, you have to look at the entire scope of the process. So there, especially for grinding, burrs can fly away, sparks can be projected in the environment. It is up to you who do the integration of the system to make sure that no accidents happen due to that either. So particles should not fly into the eye of people passing by. Sparks should not lit a fire to something in your environment. Those are safety measures that you have to do anyway. So it doesn't only have to do with the robot. Okay, so now that we have that topic out of the way, if it's not for its safety, and in my opinion, it's not because it's cheap. A cobot is no cheaper than a robot if you compare machine to machine. A cobot compared to a robot with the same payload, the same reach, most of the time the cobot will be a little bit more expensive. Okay? So it's not for its safety, it's not for its cheap. Why would you use a cobot? Well, there are two reasons left that we see in the market why people are looking at cobots. One, easy to integrate, and two, easy to operate. And those two domains might be a little bit of an advantage for the cobot for grinding. I'll explain to you why. Easy to use, easy to set up and integrate. Well, a cobot inherently has force sensing in its arm. And with these force sensing sensors, with the data from those sensors, originally meant to be safe around humans, but with that data you can also do other things. You can steer processes like grinding. You can program force compliant movements and so on. Easy to operate? Well, that is actually thanks to recent software developments that have happened and that make it possible today to program these force-compliant paths based on that data from those sensors in a very convenient way, in a very user-friendly way. And those two together give a little advantage to a cobot over an industrial robot. But of course, the cobot also has a lot of limitations. And I would like to emphasize that a cobot, whether it is for welding or for grinding, will not replace industrial robots, nor will it replace industrial robots for pick-and-place applications. It only extends the palette of solutions that an end user can choose from to solve his problem. And I think we have come at a point where we are convinced that also for grinding, For certain applications, small series, not too complicated applications, a cobot for grinding could be very useful for some companies. Okay, before we go any further into more challenging cases, I would like to give a big shout out also to Vlaio, who made this research that we've been doing for the past few years possible in the CoboFin project. So in the CoboFin project, we have the possibility to look into more challenging cases and see for which industrial cases could cobot grinding really be maybe interesting. Where could it find its place? Okay, there are two cases that I picked out from this research project that I want to show you and talk to you about what is possible. So this first case, it's a case of, like you see, it's sheet metal. Actually, it's a support of a medical bed that you see. And you see on the picture to your left, these black spots. These black spots are actually the result of welds on the backside of the plate. The plate itself has been shaped underneath a press bench. So the plate itself is double curved. It has a curvature in the horizontal side, in the horizontal direction, and also in the vertical direction. And the radiuses of those curves are varying. They are not constant. So it's a complex surface, difficult to program typically. The black spots that you see are not only decolorization, but they're also a little bit swollen material. Actually, the material has expanded due to the heat input from the backside of the weld. Now, because this is a visible part of a medical bed, it has to be clean, it has to be shiny. You can't have any bumps when you put spotlights on it. So this excess material has to be grinded away, but it is a very delicate job because the least that you grind process especially is very soft landing. Your grinding this has to land very softly on the surface. If you land hard, you get an indentation already, and also a very soft retraction. And the second big challenge was, this was programmed online, very user-friendly, but the problem was the slightest inclination that you give to the disc, you're not grinding in the middle of the weld anymore. You have to grind exactly in the middle of the weld, because otherwise you're grinding on the side of the bump, actually, and you're not grinding away as it should. So we found approaches and ways to do that to have a good result in the end, let's put it like that. And once you have found the right approach, once you have found the right parameters, also the right force with which you push to the surface, because all these movements are force-compliant movements. When you have found all these parameters, then it's rather easy to replicate on other products and so on. And you should also not forget, like I said in the beginning, this plate is pressed under a press bench, but you also have a little bit of spring back because of the elasticity of the material. And the spring back in all the different parts is not always exactly the same. So there is quite some tolerance on the incoming products. This is why also these force-compliant movements are so important. So this is the grinding step, and next is the sanding step. Okay? So the sanding step is simply smoothing out all the scratches made from the grinding. And that is much less critical to program, because as you can see, we use a soft intermediate pad on our sanding machine. That already gives you a lot of tolerance to make less accurate programming, I would say. And also the programming movements that you see, that let me try to start that movie again. Oops, that's the wrong button. So the movements that you see the robot make, they are actually movements like it was shown to the robot. It was really teach by demonstration. So you take the robot head and you simply move it the way you want it to move afterwards, and then you replay it at a constant speed. So all these software developments make this possible nowadays. Okay, so this is the different steps and the final result. Now, the last picture, when you follow the arrows, the last picture after painting is of course a very important one, because it's only after painting that you see most errors, actually, most defects in a surface finish. So the company for which we did this project wanted to do this final evaluation and actually paint one of the parts, and they found that the quality was very good within what they needed. Another also a challenging case that I want to talk to you about today is a deburring case. This is the deburring case of also composite trays like you find in the self-service restaurants when you stop at the side of the highway, of course. These trays are the result of a pressing process. So you have these flashes, as they call them in the plastic industry, burrs, or as we call them in the metal industry. These flashes have to be removed. And today, these flashes are removed in a machine. It's a machine setup. And the machine setup works like this. You have a grinding stone mounted on a spindle, and the spindle is mounted on a movable sled. And the movable sled is actually spring-loaded, and there's a template here, this plate. There's a template underneath the tray that is being worked, but the template actually pushes the sled away. So when the template turns, the sled moves away, and that way the grinding stone is always following the contour of the tray. Now, this company was interested in finding an alternative solution because they wanted to experiment with different types of trays, different shapes, different sizes, have more freedom actually. Now, if you start designing more types of tray and you start selling more types of tray, that means that your batch sizes become smaller. With the machine, if you want to change between types of trays, first of all, you need to have a template for each type of tray. But second, every time you change from type, you have switch over time from your machine. You have to make modifications to your machine. So they were looking for a more flexible way, something where they could do one tray after the other, different shapes all the time. And that is why they were thinking about a robot or a cobot for doing the deburring. So in this project, first of all, we tested a lot of different abrasive materials, because when we look at these challenges, we try to take a step back and look at it first very broadly, and then focus on what needs to be done, just to make sure that we don't miss any side solutions that could also have a big impact. Then we tested again a lot of strategies and parameters like we did in the previous project, but I deliberately put in some pictures where we have bad results. So it's not always first time you find immediately the solution. You really need to show some perseverance to find the right parameters, to find the right approach. But once you found it, you can really replicate it relatively easy on similar products of your company. And then finally, luckily, we are always happy when the results are good, but sometimes the results are not good either. But luckily, in this case also, the result was actually satisfactory for the customer. And as you can see also here, it's very important because maybe I forgot to mention, these trays are made out of chalk with glass fiber reinforcement. But it's only chalk. And you know, if you start grinding on chalk, it's immediately gone. So also here, it's very important to have a very soft landing, have a beautiful constant speed, and also to have a very abrupt moving away of the surface. The slightest few tenths of a second that you stay on the surface, you already have an indentation. Programming is not that difficult here either. It's some discrete points, and the entire movements are force compliant. So the points that you teach don't need to be exactly on the surface where it has to be ground. They have to be in the vicinity of. So that goes relatively quick as well. So, is grinding with cobots technologically feasible? We believe the conclusion is yes, but there is some side notes to make, some side remarks to make. First of all, yes, even high gloss polishing is possible. We researched in a research project high gloss polishing of metal parts for the injection molding industry, and high gloss polishing up to their requirements is possible actually. So the force feedback loops that you have in your cobot are fast enough, are accurate enough to have this good result actually. But two side notes to make. First of all, automating the movement solves only part of the problem. Very important is spindle and abrasive tool selection. That will always remain very important. But a more annoying one actually is knowing when to stop grinding is a challenge. And that will always remain a challenge in my opinion. When you have manual grinding, manual polishing, manual deburring, it's the operator who is constantly watching his work and he is constantly determining, go I over it once more or can I stop now? And when you automate things, all you have is the time that you are doing this process. The process is much more constant, so it's much more predictable. That is true. But you have variation on your incoming material, and you certainly have variation due to the wear of your abrasive tools. Now, this is a downside for automating with any machinery, but it's also a little plus side for the semi-automation or lightweight automation with a cobot. Because when you do this kind of automation, your operator is never too far away from your process. You're bringing new products and moving products away is typically something that you leave up to the operator in those semi-automation cases. And that also allows him to have a look on the quality that's coming out. He can determine whether he wants to go one pass extra over the material or whether he has to change the abrasive tools and so on. Second side note to make is ease of programming. Yes, there are softwares that make programming easy, but you have to select them carefully and you have to test, you have to show some perseverance in testing to find the right approach. Not all approaches lead to a satisfactory result for these more challenging cases. So those are the main things that I want to convey or hope that you might remember after my little talk. Finishing with a cobot is an option to consider. Time for a drink. Thank you.